anytime I'm asked to find the equation of a line, regardless of what form I want it to be in, I'm always going to start by finding the slope. And so to do that when I'm given 2 points, I'm going to use my slope formula, y2 minus y1 over x2 minus x1. Or you can switch the y1s and y2s around like we talked about. So if I do this, then I'm going to take 4, subtract -1, so y2 minus y1, and divide that by x2 minus x1, so 5 minus 3. When I do that, I end up with a 5 over a 2 as my slope. So again, that's how I always start any of these problems. Next up, I'm going to kind of fill out this chart in order. So I'm going to start actually getting the equation in point-slope form. If you recall from your notes, that was the form that looked like this. Y minus y1 equals m times x minus x1. And I'm noticing they want me to do 2 forms of this. Well, the 2 forms are going to come from the 2 points they gave me. So let's go ahead and use this first point to get the first equation written. So y, and then my y value was -1 from that point. Remember, in point-slope form, we changed those signs, though. So y plus 1 would equal the slope. Well, we found that in that beginning step. My slope was 5 over 2. And then x is x, and then the x1, again, is that point, or that coordinate from the point, and I changed the sign around to make that -3. And so that's point-slope form, at least one version of it, okay? To get the second version of it, well, I'm just going to use the second point. So same thinking, but the second coordinate up there. So this time I'll use 5, 4 as my x and y values. So my second form of this equation will look like y minus 4, because I want to change the sign. Same slope, so 5 over 2, and then times x, and then minus 5 because my x value was 5 from that point. So there's 2 different forms of point-slope form for this equation. All right, so then moving along, let's go ahead and next write this in slope-intercept form. Well, I could start the problem from scratch. We've done those problems earlier in this unit where we wrote equations of lines in slope-intercept form. But since I already have point-slope form, all I really need to do is distribute and solve one of those equations for y. And so that's what I'll do. And because each of these represent the same line, it really doesn't matter if I rearrange line 1 or line 2. I'm going to get the same slope-intercept form. So I'm going to go ahead and distribute first. So 5/2 x. And then 5/2 times -3 is going to be -15 over 2. I can use a calculator or multiply by hand if I wanted to do that. To solve for y then, I'll subtract 1 from both sides. And so I end up with y equals 5/2 x. There's my slope. And then again, using a calculator if I want to subtract those 2 parts right there, -15 over 2 minus 1 is -17 over 2. So I have this, which probably wouldn't be super easy to graph if I needed to graph it since my y-intercept is this weird -17 over 2. But I could graph it if I wanted to, or I could graph those original point-slope equations. All right, and then the last little bit of this is let's go ahead now and go to standard form. Again, I'll just use the equation that I came up with last time in slope-intercept form. Standard form, recall, looked like this. ax plus by, or those x's and y's could be switched. X and y on the same side, though, and then a, b, and c all have to be integers, no fractions allowed. So if I rearrange where I left off by getting x and y to the same side, I can subtract that 5/2 x to get it to the same side. And then equals -17 over 2. Now the problem is, even though x and y are on the same side, I don't have all integer values. And so this is the point where I need to figure out what is the least common multiple or least common denominator that I have. And it looks like all my denominators I have are 2's. And so what I'll do then is I'm going to multiply this entire equation by whatever that least common multiple or least common denominator is. Because what that'll do is have the effect of getting rid of all these fractions. And so if I distribute a 2 to all this, well, 2 times y is just 2y. -5/2 times 2, those 2's cancel out, and I'm left with just -5x. And again, you can confirm that on a calculator. If you want to do 2 times -5/2, you'll see that is just -5. And then similarly, -2 times -17 over 2, again, those denominators will cancel out, or I can confirm that on a calculator by double checking it, and I'll end up with just a 17. So I've got x and y on the same side, and no more fractions, no more decimals, so there's my standard form. So there's my equation of the line. All 3, or 4, I guess, of those represent the same line. They're all going to pass through those 2 points. It's just 3 different forms of the same equation.